Hello. In this video, we are going to take a look at our first example of using Taylor series or manipulating Taylor series to find out more information. So the first example is we want to identify the function represented by the power series, k equals 0 to infinity, 5k x to the 3k plus 2. We actually have done problems like this because the series we need here is that the series n equals 0 to infinity, x to the n is equal to 1 over 1 minus x. For the absolute value of x being less than 1. We've worked with this in the past, but now what the Taylor series section is saying is that the function 1 over 1 minus x and the power series x to the n are the exact same thing on this interval of -1 to 1. If we were to graph them both from -1 to 1, the functions would line up exactly. So if I want to know about this series, I can make it look like that function. So taking the series k equals 0 to infinity, 5 to the k, x to the 3k plus 2, want to rewrite it so it starts looking like this x to the n. So I am first going to separate out those exponents to have x squared 5 to the k, x to the 3k. I have just taken this exponent and split it up into x to the squared and x to the 3k. Because this x squared has nothing to do with k, I can pull that outside of the series. Have x squared times k equals 0 to infinity, 5 to the k, x to the 3k. This is the series x squared times the series k equals 0 to infinity, 5x cubed all to the k. As x to the 3k is x cubed to the k, and so I'm going to pull that exponent out to have 5x cubed to the k. Now we have something where we have the same setup. I can replace this 5x cubed in place in that 1 over 1 minus x. So keep the x squared out front times 1 over 1 minus 5x cubed. And multiplying the x squared in, x squared over 1 minus 5x cubed. This function is the same as the series k equals 0 to infinity, 5k x to the 3k plus 2. So there is the function that's being represented. Doesn't ask us for the interval of convergence, but to find that, we would take that 5x cubed, absolute value of 5x cubed, and set that less than 1, which would also mean x cubed is less than 1/5. And we can take the cube root to get x is less than the cube root of 1/5. I'll write that out on the side again. We have 5x cubed being less than 1. So x cubed is less than 1/5, or x is less than the cube root of 1/5. So there is our first example of working with power series to see what our other power series and their related functions.